Okay, ladies and gentlemen, this is the second video. Is section 4.3. The exercises is problem number 7. So this is the second video. Now listen, I wanted to add something to the previous problem here. I know I said I finished it, but what I want to point out here is this tree diagram really helps us a lot. It's well worth your time. The problem before was, what's the probability of getting a female, let's see here. Problem A was probability that this worker is a female sworn officer. So what we can do is we can just use this tree diagram. The fact that, being a sworn person and then being a female. So it's 66% times 11.6%. And that's, if you look back, that's exactly what the answer was. Okay, so now let's get to B, question B. Probability that this random worker is a male civilian. So it sounds very similar, doesn't it? Okay. What we're asking is the probability that the person you pick, this random worker that you pick, is male and a civilian. So we're going to use the multiplication rule number 1 again. They're independent events. And it's going to be the probability that it's male times the probability that it's a civilian. But we're not given that exact information up above. We're not given that in the given part. Okay, so we're given that 66% of the law enforcement are sworn. Therefore, 34% are not sworn. They're otherwise known as civilian, both male and female. So we got 66% are sworn, therefore 34% are not sworn. Okay. We're also given that females make up 60.7% of all of the civilian employees. Well, if 60.7 are female, then it must be true that 39.3% of the civilians are male. Okay, so we put all that together, and here's our rule. Probability male and civilian, that's the probability of male times the probability of civilian. So it's 39 point, hold on. Okay, sorry. So it's 39.3% are male, 34% are civilian. That comes from up above there. So converting the percentages to decimals, I multiply it out, and there's the final answer. Okay. Now I think that if you go back to the tree, okay, it's very helpful, I think, because we want them to be a civilian. That's 34%. That's what we just talked about. 34% are civilian. And then of those 34%, 39% are male. So this tree, you go down this branch, then you go down this branch. This tree helps us. It's 34% times 39.3%. So the trees are well worth your time. Okay, so let's get back down here again. All right, so we came up with the final answer for B. Now C, it says the probability that employee is male or is a civilian. Okay, so you see what's going on here is that every word counts, okay? It's male or civilian. If they said a male civilian, it would be male and civilian. So these words make all the difference. It's very, very important to make sure you understand this distinction. So it's male or civilian. So the metaphor I would use would be something along the lines, maybe a little bit easier to think about, is the cards. When we talk about something being a face card or being a heart, well, all of the face cards would qualify, they would count, and then all of the hearts would count. Well, some of the hearts are also face cards, so remember we had to subtract those out. So that was a metaphor. Here's another example of where you might actually use this kind of a formula here. Okay, so I guess the punchline is the word or is very important. So here's my discussion. For this problem, we use the addition rule number 2 from section 4.2 or 4-2, and that's on page 204. So there's no rule that says we have to there's no law that says we can only use stuff from this section. This is a problem in section 4.3 or 4-3, but we certainly can use stuff from anywhere in the preceding sections as well. So here's the essence of that rule. If A and B are not disjoint, remember disjoint means they don't share anything. So if they're not disjoint, if there's some overlap, well, we have the probability of A or B is the probability of A plus the probability of B, and then you subtract the probability of both of them happening. So let's put it in context with our problem. A is being male, B is being civilian. So a male or a civilian. Well, probability of being a male, probability of being a civilian, but you have to subtract away all of those guys that are male and civilian at the same time. You don't want to count those people twice. So go back and review that rule. It explains there why that works. That's on page 204 approximately. Okay? All right. So that's what I say here. The employee can be both male and a civilian. We have to subtract those out. They're not mutually exclusive. We don't want to count them twice. So what do we need here? What we need, these are the things we need. We need the probability of male, probability of a civilian, and we need the probability of being male and civilian. Okay, so that's what I have here. We need the probability of male. We need to find that one. We don't have that one yet. The probability of being a civilian, we know what that is. We found that up above. That's 34%. The probability of being male and a civilian, we found that out before too. I think that was problem A, maybe. Okay, correction. This one right here, the male and civilian, that was problem B. That's the one we just solved. And that comes out to be, if you look back, that comes out to be 13.362%. That's right up here. So 0.13362 is the same as 13.362%. Okay, so we have these three things that we need. We know two of them already, so this is the one we need to find out what it is, the probability of being a male. Okay, so how do we do that? How do we figure that out? Well, we just use a little bit of logic, really. That's why math is so great. It kind of teaches you to think in a logical way. So the possibility, or excuse me, the probability of being a male, okay, is very simple. It's the probability of being a male sworn worker plus the probability of being a male civilian. I mean, there's only two types of people in the workforce, right? You're either sworn or you're civilian. So you're a male sworn or you're a male civilian. Take those two, add them up, and you're going to get the probability of the overall probability of being a male. So probability of sworn, I'm going to let you look back at the tree that we had. Or actually, you can't. You don't have this document. I can't send you the document. There's all kinds of stupid rules. Maybe I'll talk about them later. But if I send you the document, I got to make sure that it's meets certain requirements, and I don't have time to do it. So the probability of being male sworn is in the tree here. First you're sworn, that's 66%. Then you're a male, that's 88.4%. So we got that from the tree. Male civilian, 34% chance of being a civilian, and then a 39.3% chance of being a male. Okay, which we figured that out earlier. Okay, coming back to here. You know, folks, I might just go ahead and send you this document. It's awfully hard to go back and forth on this, I know. All right, so okay, so that's where we came up with this probability of being a male sworn, probability of becoming a male civilian. You get these two numbers here, you add them up, and boom, this is what you get, 0.71706, okay? So that's the probability of being a male in general, okay? So solution of C. Okay, we are now ready to go. The probability of being male or civilian is the probability of being male plus the probability of being a civilian. Take away the probability that you are both, that you're a male and a civilian. Basically what's happening is you don't want to count it twice. You only want to count it once. So we take one of them away. That's the way I think about it. So here's the numbers. This is the probability of male is this guy. Probability of civilian is this guy. Probability of both is this guy. Do the arithmetic on your calculator. Boom, there's the answer. And that's the final answer. Okay, so I hope that helped you. I'm gonna post this, and I'm also gonna go ahead and I'm gonna post the handwritten notes that I have just been discussing with you. So this is the end of this video.